Evaluate the integral from negative pi to pi of sine of x dx. Now what I want to do is I want to draw a quick sketch of this so that we can take a look and see what we can do. All right, here is my graph. It is not perfect, but hopefully it is close enough for your liking. And we're looking from negative pi to pi. And we've got kind of two different situations going on. Part of this graph is above the x-axis, and part of it is below the x-axis. So what I want to do is I want to use one of our properties to split this up into two integrals so we can look at those two integrals separately. So if we look at the left-hand side, that's going to be the integral from negative pi to 0 of sine of x dx, plus the right-hand side, which is the integral from 0 to pi of sine of x dx. Now, if we look at each of these regions, the one on the right is above the x-axis, and it gives us a positive area of something. We don't know what that positive area is. And then on the left-hand side, we've got this region that's below the x-axis, and that contributes to negative area. So that's going to be a negative integral. But here's the thing. I haven't drawn it perfectly. The way that I've drawn kind of looks like this region is larger than that region. But that's not actually the case. If you think of sine of x, that is an odd function, meaning that sine of negative x is equal to negative sine of x. And what that means is that this has rotational symmetry about the x-axis. So if we were to rotate this 180 degrees, this region would go straight here, and this region would go straight here. So these areas are equal to each other, except when we're looking at the integral, one of them is a negative value, and one of them is a positive value. So what that means is that these two quantities are opposites of each other. One of them is a positive amount, and the other is a negative version of that same amount. And when you add two opposites together, two opposite numbers, like 5 and negative 5, or 3 and negative 3, or pi and negative pi, you end up getting 0. So in the end, this integral is equal to 0 because we have the same areas contributing positive and negative amounts. And in fact, this would work even if we were dealing with a function that wasn't sine of x, so long as it is an odd function. Because if it's an odd function, that means that the areas are going to cancel each other out. Part of it's going to be positive, part of it's going to be negative. And we actually can come up with a new property here that says that if we are integrating from negative c to c, right, we need those limits of integration to be opposites. We need to be looking at the same distance on each side. If we are integrating an odd function, dx, from negative c to c, that integral has to be equal to 0 because those areas will cancel each other out. So another interesting thing we can think of when we're dealing with certain integrals.